I'm a hydrogeologist. My motto in life is think out of the box. My name, Marcel. My experience, groundwater and soil contaminations. I'm the creator of Geo RGB, a channel of geographic information systems, GIS, geology, hydrogeology, and contamination. The purpose, the objective, the goal, the intention, the target, the desire. Share my experience and acknowledge to create points of discussion. The Geo RGB community. Promote the use of free and open source software. A free digital society. Provide technical advice to environmental companies. An opportunity for professional growth.
Hello guys and welcome back to my channel. In this occasion I'm presenting the Geostatistical Analysis Course related to the creation of groundwater flow maps with Kriging Interpolation. We are going to be working with R and Rstudio for the geostatistical analysis and graph design, and with QuantumGIS for the final map edition. We are going to compare the results we get with the Geostatistical Analyst extension of ArcGIS to see how we can get the same results. However, ArcGIS is a private software, but Rstudio and QuantumGIS are open source and free software. I am going to create a series of video tutorials where you are going to learn how to create a Kriging interpolation successfully. Unfortunately, Kriging interpolation is a kind of black box where most of the people just press the button next without understanding what is the math behind the Kriging method. However, in R, there is no button for next. In these tutorials, I am going to explain with examples, step by step, the spatial analysis methodology, where I'm going to be talking about exploratory data analysis, experimental semivariogram, model semivariogram, cross-validation, Kriging interpolation, and also at the end we are going to be working with the map edition with QuantumGIS and also reporting results. The first video is an introduction about how to download Arc and Rstudio, load the data in QuantumGIS, and load the data in ArcMap. Let's go to do it. R is a programming language for statistical computing and graphics. It's the reference software in the world of statistics, and one of the most powerful and efficient tools on the market. On the other hand, Rstudio is a software that will allow you to use all the power of R in a friendly software interface. First, let's go to download R. After finishing the installation, you are going to get a couple of icons. The first one is for the version of 32 bits, and the second one is for the version of 64 bits. Now, R is already in your computer and you can use it. But as you can see, this interface is not really good and it's not really friendly. That's the reason because we are going to install now Rstudio. Now Rstudio is ready to be used. Now I'm going to show you how to change the appearance of the screen. Just go here to Tools, Global Options, and here in Appearance. I'm going to choose, there are several that you can choose, but the one I like it is this one, and this one is the one I'm going to use. Okay, and also I'm going to show you how you can create a new file. Just go here. Well, it's going to be a new project, new directory, new project. Select the folder. I'm going to leave this one by default because it's the one I want. Put a name here for the project and create project. Now here in this screen you have the name of your project and also here at the top, as you can see here. And also I would like to use a new R script, this one, and this Windows is going to be open here. This is the configuration we are going to use for our course. Then for save the scripts, just press here, select a folder. I'm going to keep in the save folder as I save the project, and even the same name, but I'm going to remove this one here, just leave Groundwater and save. Okay, and we have the script here. This is the project and this is the script. Here you can make the panels smaller, bigger. You can move according to your necessities. Okay. And also in each panel there are different tabs. We are going to see all these tabs during the course, but to have a general idea, for example, when you start to write a script, for example here 5 by 5, and then if you put here, for example, A is equal to 5 by 5, and then run the script, okay, you are going to have the results here and your variable is going to save here. It means A is equal to 25. Then if you put here, for example, just A and then run, it's going to be just 25. Then also, for example, if we put here a question mark and then here, for example, license, we are going to get information about the license. Run, and the information is going to be displayed over here on the help tab. Also here in history you have the history of your scripts. For example, we did these 3 now, 1, 2, 3, and they can save here. If you double click here, their one is going to appear here. Then you can save your scripts here, remember that one. And also when you close, the software is going to ask you if you want to save your project, right? Then always press save to make sure you save everything, right? Now let's go to see the data we are going to use, and let's go to load that data on Quantum GIS. I'm using Apache OpenOffice. This one is an open source free software. It's like a Microsoft Office, right? And then let's go to open the spreadsheet. And I'm going to copy here the data I need. As you can see, we have 4 columns. One is for the X, another one is for the Y, another one is for the groundwater elevation, and another one is for the piezometers label. Okay. Then let's go to save this file, save as, and then we want to save this file as a CSV, this format, and we are going to save this one with the letter A. Okay, select the folder you want to save. For me, this folder is good. Save. I want to keep the format. Okay. Okay, and then close. And now I'm going to open Quantum GIS. Then click here, open data. Select this option here. Look for your file. Is this one? Okay, you have to look for your folder. This one is my file. Open. Make sure you have this option. For this one, everything is good. And here you have to select this option here and to make sure you have X, X, and Y, Y. Okay, because there are different parameters. And then select your reference coordinate system. In my case is this one. This one is good, but if you want to change, you can click here and look for your coordinate reference systems. And then you have here your data. As you can see, the 4 columns, and then add, close. Then if you want to look for your location with a Google satellite map, just here, satellite, and you have here your location. Let's go to change the color of the docs. Properties here to make the docs more visible. Select here for a red color. Apply. Okay. I want to clarify, and this has to be very clear, that the location of the piezometers are not real. The groundwater elevation is not real. I created this data for making this tutorial. I decided to use a real location because for the final map edition, it's better to work with this kind of data to have a better understanding about how to present and expose the data. Now I'm going to show you how to export all this data to shapefile. Because as you can see, if you go here, properties, information, for this file, the information is stored in a delimited text file, and we want a shapefile, and then we can open that shapefile with ArcMap. Okay. And also you have different information here, as you can see, the reference coordinate systems, the extension, the units, and how many features we have. Okay, to do that one, just click here, right button of your mouse, and go to export, save feature as, then select the format you want. In this case, we want a shapefile. Then select an M and also select a folder. For me, this folder is good. I created a new folder to save all the shape files. Just double click, and here is going to be, the name is going to be data. Save. Select the coordinate reference systems you want. For me, it's going to be the same. This one is good, but if you want to change, just click here and look for your coordinate reference systems. Then for the other ones, it's okay. You don't have to do anything more. Then press OK. And then we can remove this one because we are not going to use this one more. Delete, remove layer, OK. And now if you go to information on properties, you are going to see that now is stored in shapefile. Okay. Now I'm going to show you a little bit about this data. Open attribute table. As you can see, we have the coordinates, UTM coordinates, X, Y, we have the groundwater elevation, and we have also the piezometers. Okay, we have in total 57 piezometers, and we can add some labels to see where they are located. And also for the groundwater elevation, we have a millimetric precision, because as you can see, we have 3 decimals here: millimeters, centimeters, decimeters, and meters. Okay, let's go to put some labels on the map. Then go to labels, single labels, and we can choose the parameter. Let's go to see, for example, the piezometers location. Apply OK. Let's go to take out the image. We have here all the labels for the piezometers, and now we can see the labels for the groundwater elevation. Apply. Okay, it's this one. Now you can have a better idea about the distribution of the piezometers and the groundwater elevation. As you can see here, we have the minimum value, and over here we have the maximum value. Okay, the groundwater flow direction is in this direction, but we are going to do the Kriging Interpolation to have a better understanding of the flow of the groundwater. Now I'm going to load the data on ArcMap. ArcMap is a product of ArcGIS. As I said at the beginning of this video, we are going to compare the results we get with ArcMap with the results we get with Rstudio and QuantumGIS to see how both results are really similar. The only difference is that Rstudio and QuantumGIS are open source and free softwares, but ArcMap is a private software. Then the goal of this tutorial is not only to show you how you can make a professional Kriging interpolation, it is also to show you how good are the free tools to do Kriging interpolation compared with private software. Then just click here to add the data. Click this option here to look for your folder. I have my folder already here, and this one is my data. As you remember, this one is a shapefile. Add. Then if you want to add a base map, you can go here, add a base map, and we can add a satellite imagery. Then if we press here, we can go to the attribute tables to see that we have the same as we have in QuantumGIS. Then here, that is the extension we are going to use for this project, the Geostatistical Analysis. Then if you click here, you have all the options we are going to be working on. We are going to create all these options with ArcMap, and we are going to do the same with Rstudio. And also here we have to do the Kriging interpolation. There are several options that we are going to see how to do all this stuff with Rstudio also. Okay, this is the end of this first introduction. For the next video is going to be the exploratory data analysis of this section here, where we are going to see how to create a histogram, normal QQplot, Voronoi map, and trend analysis with ArcMap compared with Rstudio. Okay, thank you very much for watching this video, and see you on the next one.